electronically. So controlling them electronically, we have to come this other side where we have the start button and we close it, and then we have other switches of uh, individual pumps. So you want to pump, you want the to pump the water, then that means you have to go to the water pump, and it is right here. So take a look at these two normally closed. So once I press the water pump to go on, the two of them open up. That means even if I close here or close here, there is no other pump that is going to turn on. That's the use of interlocking. And this indicator is always on the control panel where it is going to be showing which pump is running at a particular moment of time. So, to improve the simplicity. So, to go to another pump, I must have to first turn on this pump and then I go to spirit pump. And you can see when I press the spirit pump, it opens and neither of the other two can turn on. You see, none of them can turn on till it takes time to fill in the spirit, and then you turn it off and then you do the mixing. So brothers and sisters, this is where I have done the manual mode, and this is something that you can do manually in the control panel to run. But yes, if you're interested, we are going to have another video about doing it automatically using a PLC, which I'm going to be releasing in a few coming days or hours. So just stay on and you will enjoy it. Thank you so much.
Hey, welcome everyone. And in today's video, we are continuing up with industrial automation. If you're new here, you can check out our videos and you know what we have been dealing with, and maybe you can delight free for us so as you can be part of our family. So in this video, today I'm not directly taking you to the PLC programming of this kind of a setup, but actually what I'm going to do is to make you aware that we can use this automation and achieve it using normal wiring. But as well, in this kind of a video, I'm going to take you through how we can do manual operation of this kind of a system, and how we are going to achieve the wiring. So this is a setup, some setup I met with a customer some time back, and he was manufacturing like beverages, like making spirits. So we have 3 different tanks, and this is a water tank. This is a spirit tank, and this is where they mix from. So in this place where they are mixing from, is where the main process is going for his final product. It is none of our business. Our business is to know what the client wants. So in the first place, he has a water tank and he wants water to fill this tank up to a particular level. So when this water reaches this level, we want to soak this one, and then we want the spirit pump, this pump over here, to pour in the spirit up to this level. And once this tank is full, then we have to stop this, and this one was stopped already. We have to start this motor here that is going to mix the whole entire process. So this takes time t, let's say 30 minutes, because he knows his process and we want to know like entirely how it takes. We can do estimations. Maybe if it is a 300 liter tank, it's going to take like 30 minutes, and so if you have like a 500 liter tank, it's going to take around like 50 minutes, something like that. So once you get done with this, you have to now activate this solenoid valve. So basically, maybe this kind of a client can have like this tank, or maybe have a source of water that is always pressurized. Let's say talking about like the national water grids and something, which have already pumped water, like come with pressure or at a particular head. So you don't actually need a pump. But I think for a spirit, you must be needing a pump. There is no spirit that is gonna, maybe if the tank is raised up and then there is a particular head, and then the water, the spirit can flow by gravity. So it all stays the same. Instead of having a pump, we are gonna be having like the valves. And these valves are electronically, they are electronic. You can control them electronically by energizing their coils. They are the solenoid valves. So this is the kind of a system that we want to actuate inside a control panel. So inside the control panel, we have a few number of inside the control panel, we have protection devices. That's where you find like isolators. This is a switching one, switching the isolator. Then protection, you find we have like circuit breakers. You find we have MPCB. This MPCB is the motor protection circuit breaker. Most of the people, they are not interfacing with it because of its scarcity, but it is a new technology as well. It combines like instead of having an overload relay, and then you have the circuit mini amateur circuit breaker, it combines the both. So we have the MCB fuses and all this. Then you go to the switching as well, we have contactors. These are what we want to see, and we work with them on the hardware. So I have already made the simulation. Let me dive through it and quickly see the snippet. Then in the second video, part 2, we are going to do this entire process using the PLC. Thank you.
Someone could have actually asked why I'm not using like AutoCAD Electrical. AutoCAD Electrical is something that I would use if I wanted to just generate the engineering diagram for the control panel. But in here, I want to just check out like if my flow of power is correct, because in AutoCAD you will not know if you're right. Maybe if someone actuates your diagram, if it's going to short circuit or not. But in here, if I am to play it over here like this, and I switch on the all the isolators as I told you in the other video, and then I switch on all circuit breakers, and then I go to the control circuit, I press start, and then when I say my water pump is supposed to go on, you can see water pump indicator is showing it is on, and here it is running. Remember, we are using three phase. So this is something you cannot achieve in AutoCAD Electrical, because AutoCAD Electrical, you're just producing a diagram. So let me explain real quick how I managed to achieve everything. So here, this is my power supply, because I told you we are dealing with three phase. In this kind of a system, we're just dealing with three phase. I could have implemented it with single phase, depending on the type of client you're having. If it is an industrial level and they are having three phase, or maybe the equipment is three phase, you have, of course, to abide with what they have. So I have my power supply over here. So it's a three-phase, four-wire system. That's because I'm catering for an unbalanced system. If it was only balanced, I could only be having three-phase, three-wire. So when I reach, when this is my power supply, maybe I can consider this as a bus, my bus bar in the control panel. This is your bus bar in the control panel. And from there, you get three wires that are connecting to your main isolator. This is your main isolator, the main switch. And then from there, you have three different isolators that are going to be rated on it depending on the motor you want to run. So this isolator over here is corresponding to this motor here, and the same. So from this, this is the line of isolators. So that means your control panel is going to have three isolators, and then three circuit breakers. The an isolator is only a switching device. It's not providing any protection and stuff. But then a circuit breaker is gonna be like a switch as well as a protection device. So in any case, there is an overcurrent somewhere or a short circuit, this circuit breaker is gonna open up, and this is not in an isolator. An isolator, once you have switched it on, it is mechanical. You have just put it on by yourself, and it will require you to put it off by yourself. But this circuit breaker, it has condition. If you go through an overcurrent or an instantaneous current, that is a short circuit current, it is going to open up. So from there, we go to the line of contactors, and these contactors are going to be controlled through a control circuit. You're not going to control them using your hands. So from the contactors, now you can power your three-phase motors. And then the main cake is over here, the control circuit. In the control circuit, as you can see here, I powered the control circuit using this line over here. Where is it? I used line one, and line one is here. So I power the control circuit. I have the start or stop button or switch. Once I press the switch, it has to give me that I connected in series with three parallel switches of this water pump, the spirit pump, and the mixing pump. So from there, I use interlocking. These are the interlockings from these different contactors here. I use these interlockings. Basically, I'm going to explain when I'm simulating that if one pump is on, if this pump is on, one of its contactors over here is going to provide an interlocking here. It's going to open up. So when it opens up, that means even if I turn on another pump, it is going to not turn on because I only want one pump to be running at the go. So take an example. In here, if I turn on this and then this gets energized, the contactor for the mixing pump, the water pump is here and it is named KM1. So the KM1 contact has to be in the both here. So literally this means that this KM1 here, which is normal cross, is going to open. So even if I start this pump, there is no way I'm going to energize this. So interlocking, if you want a video about interlocking, you can mention it to me, but if I believe everyone is good with that right now. So let me simulate it. uh, I have to close this isolator and then it gets me powered with my control panel gets powered, and then I close the three isolators, then I also close the three circuit breakers. So right now you can see all the circuit, the power has flowed, has gone through up to the contactors, and these contactors, they cannot be powered mechanically. I mean, like, you're not going to go to the control panel and you press the contactor to go on. They are controlled electronically. So controlling them electronically, we have to come this other side where we have the start button and we close it, and then we have other switches of uh, individual pumps. So you want to pump, you want the to pump the water, then that means you have to go to the water pump, and it is right here. So take a look at these two normally closed. So once I press the pump, the water pump to go on, the two of them open up. That means even if I close here or close here, there is no other pump that is going to turn on. That's the use of interlocking. And this indicator is always on the control panel where it is going to be showing which pump is running at a particular moment of time. So, to improve the simplicity. So, to go to another pump, I must have to first turn on this pump and then I go to spirit pump. And you can see when I press the spirit pump, it opens and neither of the other two can turn on. You see, none of them can turn on till it takes time to fill in the spirit, and then you turn it off and then you do the mixing. So, brothers and sisters, this is where I have done the manual mode, and this is something that you can do manually in the control panel to run. But yes, if you're interested, we are going to have another video about doing it automatically using a PLC, which I'm going to be releasing in a few coming days or hours. So just stay on and you will enjoy it. Thank you so much.